right, guys, this is going to be the recording for Traits and Reproduction 3.1. So you were either doing this on Wednesday the 17th or Thursday the 18th. And so today we're still investigating how genes are passed and we're looking closely into sexual reproduction. And so I will go through those definitions again, but if you notice down here, those are ones that we want to enter. But I'm going to probably wait until next week to do that because attendance has been a little wonky this week with the bad weather and power outages and internet outages and all of that. But today we're looking into identical and fraternal twins and how that happens. And so you can see here, I put a nice visual in here for you. And so this is fraternal, and fraternal twins are from two separate sets. So two sperm and two eggs separately fertilize and then go through the process. And so there are two separate placentas, which is the sac that the baby grows in inside the womb. And then identical twins are very rare for this reason is that it's one sperm and one egg, and that egg splits. And so then um, they could have separate or a shared placenta depending on when it splits. And so that's cool. And that's why it's so rare. And also, they're literally identical, same gender, same everything. So it's very cool. And I know there's a few sets of twins. I know like 2 years ago we had like triplets and all this crazy stuff. So the assignment for today, the first part, it's kind of a two-parter. The warm up, oops, now my thing's frozen. There we go. The warm up is looking at this same chart that we've looked at before. And so looking at this family of spiders. And last time we looked at how all these different proteins made the different flexibility and about how they had different gene versions. And so F1 matched the number one protein. And we went through and filled in the chart. And then so down here, it is going to be the similar claims and question that we've been looking at throughout this whole time. So the question is, why do traits for silk flexibility vary within this family of Darwin's bark spiders? And so the idea is that we have these three claims that we've seen, and you might have been going with the same claim this whole time, which is great because that means you were onto it from the beginning. And it's okay if you've changed. And so the idea is that we're kind of coming to the end of the unit. And so since we're coming up to closing out, I wanted you to put your thoughts on what you think now that we're close to being done. So you're going to pick one of these three claims. So claim one, the offspring have mutations that affect their traits. Claim two, the offspring's traits depend on which parent the offspring received more copies of genes from. And then claim three, the offspring received different combinations of gene versions from their parents. So you're going to tell me which claim you agree with and why. And you should have a good idea at this point. And then the other part of our lesson today is this reading about identical twins and why they're so rare. And you can see I have it linked right here. And then down here, I have some boxes that I want you to fill out. I kind of planned this lesson to be more led by you, and you won't really need me as much because I knew we'd have some issues with these crazy storms this week. So you'll go through that article and kind of pull out these important things on your own. And then next week, when things get more back to normal, we'll dive in, we'll use the simulation. I'll talk about sexual reproduction and inheritance and all of that stuff. So that's that.